analyze a circuit. So let's see how we can analyze a circuit using the mesh current method. So assume I have the sources here, which is going to be 100 sine 1000 t, and then it is connected to I would say the R1. This is 50 ohm, and then it is connected to the current source. So cosine 1000 t, and it's connected to, again here, another resistance R2, which is 100 ohm, and then there is a capacitance here, which is going to be so the C is going to be 10 microfarad, and down here we have an inductance which is the L is going to be 50 microhenries. So assume we have this circuit and we want to use the mesh current method to analyze this circuit. So what we do is just, first of all, we have to go ahead and convert the sources to the phasor. So this one, the first one that I have is 100 sine 1000 t. So I have to convert it to the cosine. So it's going to be 100 cosine 1000 t minus 90. So if I convert it to phasor, so it's going to be 100 with angle of 90 degrees, and it's going to be in volts. So it's a voltage that we have. So it's going to be in the volt. The next one is this one that we have, and so it's in the volt. And again, this one you can convert it if you want it into rectangle, because then negative 90, so it's going to be negative j100 in case that you want it to other one. This one is the cosine 1000 t. Again, we can do this calculation because look at here, the omega t here and omega t here is the same. If they were not, we cannot. So this magnitude is 1 here. So if I run it to phasor, the magnitude is 1 and the angle is 0. So I can write it as a 1, 0 amp, or it's just simply it is 1 amp, because this is only real value, it doesn't have any complex. But so this is 1, 0 or 1. Now I have to go and find the impedance for each of the element I have here. So I have two resistance. So I know the Z for R1 is just simply R1, and it's going to be 50. Or Z for R2 is just simply R2, so it's going to be 100 ohm. And then I have this one, Z for the C is negative J over or omega c, which is going to be negative j divided by omega. So look at here. This is the what we have here. This is the omega t. Therefore, the omega is 1000. So have the omega is 1000 and times the c, which is 10 microfarad. So if you do the calculation, it's going to be negative 100, negative j 100, or 100 with angle of negative 90. The same for the ZL. So the ZL is going to be j omega L. So the j, the omega is 1000 and L is 50 micro. So go ahead and 10 to the negative 3. So eventually it will come out as a j 50, or 50 with angle of so you can write it, this one is 100 with the angle of negative 90, or this one is the 50 with angle of 90. Remember that these two, when you don't have any r value, you're either going down, is negative, or you're going up on the imaginary axis. Anyway, in case that you need them. So now that I have all the sources and impedances in phasor and impedance, so I can go ahead and redraw this again. So this time I have this one plus minus, and so it is going to be 10 negative, 100 negative 90, or it is equal to negative j 100 here. Then we have here the z for R1 is 50. And then we have this source here, which is just 1 with the angle of 0, or just 1. Or so it's simply 1. Then we have the z for R2, which is 100. Then we have the c, the z for the c, which is negative j 100. And then we have the inductor with the impedance of j 50. So now we go to do the mesh current method. So in the mesh current method, we are going to have the assume there's two current in there. So we are going to assume this is going to be the I1, and this is going to be the I2. So the very same method that we use in the mesh current. If I want to do it here, so it's going to be the I1 as a function of time, and the same here. We are going to have the I2 as a function of time. So now that we have everything in the phasor and impedance, we are doing the very same method that we did it as everything was resistance. So first of all, consider this super mesh here, this outward super mesh. So if we if I compare the super mesh for outside, so the very first mesh that I'm going to consider is that start from one corner here and goes back to where I started. So if I consider I started from this corner here and I assume this is going to be my mesh all the way back. So if this is going to be my super mesh, so write the KVL there. So I know that for super mesh, I know that so um, so basically what I'm going to do is the KVL at this point. So for the if I write the KVL for the super mesh, then what I have is the sigma V for that super mesh should be 0. If I start from here, so what I have is the very first thing I have is then this one, which is going to be the so I first hit the negative sign. It's going to be negative, and its magnitude, which is going to be, I put it because I'm going to add them together. It's easier to put it in the rectangular form. So it's going to be negative J 100. So this is this voltage here. Then I have the voltage at R1. Then I have the voltage at R2. Then I keep going. I have the voltage at C. Then I have the voltage as L. Is going to be 0. And then I come here. So if I move along the outside mesh, I reach this voltage source here, then the voltage of this one, then voltage of this one, then voltage of this one, then voltage of this one. They will come back here. Why I cannot use either of the I1 or I2 meshes? Because I have the source here, which there's no way I'm gonna know what's the voltage in that source, the current source. Because I cannot know the voltage in the current source, I have to somehow skip it and go around. So if I go ahead and substitute all the values there, so it's going to be negative, negative, so it's going to be J100. Then for the VR1, I have the um, ZR basically, the I1 here for this one. Then if I come here, I have the um, ZR1. I have the ZR2 I2. Then here I have the ZC I2. Then I have the ZL I2 is going to be 0. So if I substitute this, so it's going to be J100 plus the ZR1 is going to be 50 I1 plus the ZR2 is going to be 100 I2 plus negative J. So it's going to be negative. So let's put it negative. Negative J100 I2 plus J50 I2 is going to be 0. So all I did here is that I substitute all the voltage with this equation of the voltage is equal to Zi for each element here. So each voltage here, replace it with the Zi, equivalent Zi. So it's gonna what I have. So eventually, if I simplify that, I'm gonna get the 50 I1 plus 100 minus J50 I2 is going to become negative J100. So this is my first equation. So I have one equation, two unknown. I have to go ahead and find another equation. Remember that when we have the source voltage method, like the mesh current method like that, we could have write an equation also for this connection here. So if I go ahead and say, okay, assume, just call it, this one is going to be node E, and assume this will be node F. Just name them to know what it is. So I go ahead and draw that node. So here what I have is that I have the node E, then I have the current source. So I have the current source, and then I have the node F. Have the node F. Now, for this case, I know that the value here is 1 with angle of 0 amp, or basically just simply 1 amp. Now I know in that, if I go back, I know the I1 goes downward here and I2 goes upward in that one. If I rotate it in this one, the I2 goes upward, the I1 goes downward. So I'm gonna put it there. So I1 goes like this and I2 goes like that. Now I know in this case, I know that the I from E to F is just 1 amp because the source is there as 1 amp. Also, I know that the I from E to F, if we look at the here, I from E to F is the I2 minus I1. So I have the I2 going up, I1 going down. So the difference between them is the, so therefore, I know that the I2 minus I1 should be 1. So this is the second equation I have. So this is the first equation, and this is the second equation. Now if I write both of them together, so I'm going to have 550 I1 plus 100 minus J50 I2 is equal to negative J100. And then I have this one negative I1 plus, so here if I negative I1 plus I2 is 1. I just replace these two together. Now I have this system of equations, so I can go ahead and say that I have 50, then I have 100 minus J50, then I have negative 1, I have 1, and then I have I1 and I2, and then I have negative J100, and I have 1. So if I go ahead and solve this system of equation, what I'm going to get is that the I1 would become negative 0.5, negative 0.5, sorry, negative J0.5, and the I2 would be 0.5 plus, sorry, negative J0.5. So these are going to be the magnitude if we solve this equation. And again, if I go ahead and write the I1, so the I1 is negative 0.5 minus J0.5. So you can write it as a um, uh, polar format. So it's going to get 0.7071 with angle of negative 135 degrees. And then if I have it, so I can go ahead and say that the I1 T is time format, in the time format. So this is the phasor, so I can convert it to the time. So it's going to be the magnitude, it's going to 0.7071 cosine omega t, which is go ahead. So this is the omega is the one, this is omega t, the 1000 t. So it's going to be 1000 t and plus the angle, which is negative 130, negative 135, 135. So this is the IT that I'm going to have in here. Or it's the same way I can also find the I2 as well. So this is the way that we can use the current mesh method to analyze the AC circuit.